Here's a project I call Tilting Arpeggios. As I tilt the Circuit Playground Express, it plays different notes from arpeggios. And I can change the key. I can go up a fourth by pressing the A button. I'm holding the CPX upside down, so the A button is on the right. Now I'm flipping the switch so that instead of hearing a dominant seventh chord, you're hearing a blues chord. Let's take a look at the code for tilting arpeggios. You've seen how it works, so I won't read this to you. Let's scroll down. We're using Adafruit's CPX library. And here we're creating some constants used for the kind of music theory, including the arpeggios, so where on the 12 semitones in the octave the arpeggios fall for the dominant seventh and the blues arpeggios, how many octaves we play over, the starting note, this is a B flat, and the minimum length of time that a note plays and the time after which holding down a button causes it to advance to the next place. There are several classes in here. Let's just collapse some things so you can see the general structure of this one module. The program is just a single module. The main class is tilting arpeggios, and we create an instance of it and then run. There's also the button detector that handles the logic of the buttons advancing to the next position in the circle of fourths, to the next key. And the frequency maker, that's probably definitely the most complicated part, that finds the frequencies given the arpeggio you've chosen and the key you're in and the tilt of the CPX. So where should we start? Maybe we'll do a top-down approach, and we'll just look at the run method here. So now we've expanded the tilting arpeggios class, and we're looking at the run method. And you see that this consists of a loop that goes forever, and it processes button presses and changes the tone when needed. Those are the two main things it does. Why don't we look at process button presses? That's here. And there are two buttons, A and B, which we refer to with the numbers 0 and 1, respectively. And we check to see if they're pressed. And this logic here associates a direction with each button. So the A button advances, and the B button goes the other direction. So that's what the positive one and the minus one mean. Then, using the button index, each of the two button indexes, we call advance for the direction that was that's associated with that button if the button was pushed. And if the button was pushed, then we also update the pixel. So we have a few things to look at here. Let's look now at the button pressed. Here we are now in the button detector looking to see if a button is pressed. So this is called with the index of the button, 0 meaning A, 1 meaning B. This code also limits the repeat rate. And if the index is 1, that means the B button, otherwise the A button. And simply by evaluating this expression, we get a Boolean that indicates whether that button is pushed. So we do that. And if the button is pushed, then we see what time it is now, not the actual time that we're used to, but a monotonic time that we don't know. It doesn't have any meaning other than a relative value since the program started, I believe. And we see if enough time has passed since the button was last pressed, or in other words, if we're allowed to observe a button press now. If we are, then we reset that to some point in the future. And then we return true, because the button was pressed at the right time. Otherwise, we return false. Okay, going back now to where we called this pressed method from. And that's here. And now let's look at the frequency maker, its advanced method. So we're going there now. Here we are in the frequency maker, the advanced method. Well, what's it going to do? It's got a circle position, the key that it's in the circle of fourths. And it's now going to add the amount to it, and the amount is either +1 or -1. So we're either moving forward or backward in the circle. And since it's a circle, we're using the modulo operator with the modulus of the number of half steps in an octave. So once we get up to 11, then we advance again. That doesn't take us to 12, it takes us to 0. And then the key offset finds us the key given the fact that there are a certain number of half steps in a fourth, and also doing the modulo operation. Okay, going back now to where we called advance from, which is here in process button presses in tilting arpeggios, the main class. Now we need to update the pixel so that we now show the new key we're in. And to update the pixel, we need to know the circle position we're in. That comes from frequency maker. And let's go look now at update pixel. Here we are in tilting arpeggios update pixel. And this manages the display of the neopixels on the neopixels of the current circle position. We turn off all the lights. And then here I'm going to show you a little picture how I worked out how to come up with this expression. This is a little cryptic. It has to do with the fact that you hold the CPX upside down when you play it, and also that the indexes for the neopixels increase going counterclockwise, which to my mind is counterintuitive for most needs where you're showing a scale that's increasing clockwise. So let me show you how I came up with that formula. All right, so here the CPX is tilted the way, I figure people will hold it by the USB cable. So this is upside down really. And the neopixel indexes are numbered in this way: 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. But the one we want to have lit first is this number 4, because that's really at the 1 o'clock position if you're holding it upside down. So I made a little spreadsheet of the key indexes. So this is the first key. This is when you go up a fourth again. And the light that I want to have on. So 0 gives you 4. 1 should give you 3. 2, 1, 0. And then the next one should be 9. So 4, 3, 2, 1, 0, 9, 8, 7, and so on. And also, since there are only 10 lights but 12 keys, we have to have a way to reuse 2 of those. So when maybe you noticed in the video when I got to keys 11 and 12, or if you're counting from 0, 10, and 11, the lights turned yellow for here and here. Okay, so I then graphed these 2 columns, and that produced this. So what kind of function is this? What can I do with that? And it's got this split in it here. Conveniently, the modulo operator can handle that split. And here, now let's go back and look at the formula. So 4 minus circle pause, modulo 10. 4 minus circle pause. Here's circle pause. 4 minus circle pause gives you 4, 3, 2, 1, 0. modulo 10 though. So 4 minus 5 would give you -1. Is that right? -1 modulo 10 is 9, and so on. All right, that's how I arrived at this, and that works very well. That sets the pixel index, and then the business of the color is if we're less than or equal to 9, the circle position, then we use green, otherwise we use yellow. And then this is the Adafruit library code to set the color of the pixel at this index. All right, great. That was a little complicated. Now we'll go back to where we called update pixel from, which is here. Okay, clearly there's a lot more code to go through. I think I'll go through this just in the order in which it appears here. We'll see what we haven't covered. Okay, the constructor for the frequency maker. What do I want to talk about here? This is really complicated. I'm going to gloss over a lot of it. This is where we calculate the frequencies of all the notes in the range. We're kind of pre-calculating them. And here's this calcfreq function that uses the fact that when you go up an octave, you're doubling. So we can use 2 to the power of something over 12 to find the frequencies for the notes. And this only runs once. It's not too expensive. And the alternative is pasting in a big list of note frequencies for the range, which I'd like to avoid. And also it's kind of fun to think about the physics of sound and have this formula maybe make people think about that. Okay, then we create arpeggios, and the arpeggios consists of the indexes into the notes. Circle position, key offset. Okay, so again, I'm going to gloss over a lot of this. Creates arpeggios. This creates a single arpeggio. This is the advanced that we looked at before. The function that provides the frequency is important, a little bit complicated. I think maybe we will try to look at this. It takes the normalized position, which is a number between 0 and 1 that indicates the tilt on the y-axis for the CPX that you're holding. And it also takes which arpeggio is currently selected. And so the first, on line 57 here, we find the selected arpeggio note indexes. So this is a list of the indexes, like 0, 3, 5, or whatever, into the notes for the particular arpeggio. And then we need to know the number of notes in that arpeggio. And then we multiply that by the number of octaves in the range. We add 1. That gives us this. And now we multiply that 0 to 1, the position of the tilt, by this. And that gets us to a note index. And then we use that note index to get us the right note inside the note frequencies list. And then we return the frequency. I kind of glossed over that, but there it is. Okay, that's it for that class. Now the button detector. I think we've covered enough about this. What else more about the main class? We dim the pixels a little bit. We create the frequency maker. We set the initial pixel setting. We create a button detector. This is optimizing so we don't do extra work if the frequency hasn't changed. This handles not changing the pitch too often. Okay, what else here? The tilt, let's look at this. All right, so this is tilt within the main class, tilting arpeggios. And it's used here when we're changing the tone if needed. We need to know the tilt. So this takes the CPX acceleration on the y-axis and turns it into a number between 0 and 1. And also constrains it to the amount of acceleration that would be imparted by the normal pull of gravity, which is 9.81 meters per second squared. And we negate this because we're holding it upside down, I believe. Okay, that's all I'll say about that. What else? I think maybe we'll leave it there. So take a look at the code, play with this, modify it if you like. Leave me a note if you have any comments, and I'll see you next time.